This video is going to specifically talk about the material in our textbook for Chapter 1. And I will do a few of these videos for those of you that like to hear a full lecture, so to speak. You can listen to it and put yourself to sleep. So the beginnings of Chapter 1 is just an overview of programming. It talks about computers and software and the hardware. And you can go through these PowerPoint slides. I'm not going to stop and go through all the definitions. I'm just going to highlight things. And so the PowerPoint slides are available on our resources folder. And this is for our Gaddis textbook. It is Gaddis Introduction to C++, and I believe it's edition 8. So we have hardware, and this talks about output devices, input devices, secondary storage, and that you have a CPU in the computer, and main memory is RAM. RAM stands for Random Access Memory. In the CPU, you have a control unit that helps retrieve and decode all the program instructions. And then you also have a separate unit that does all the math, and that's called an ALU, or an Arithmetic Logic Unit. And so that's the thing that's programmed to actually do all the math. And then the control unit helps coordinates all of the other operations within the computer. So this particular slide talks about the fetch, decode, and execute cycle, and you will run into this from time to time in programming textbooks. But a fetch will get the instructions from the memory. The decode will interpret the instruction and generate a signal, as it says here, and then execute will tell the computer what to do. Main memory holds instruction and data. It is volatile. That means that if you ever hit the power cord and your computer goes off, you lose that. That is called random access memory. And just as a tidbit of information, I don't think these slides talk about it, but there is something called ROM, R-O-M, and ROM is read-only memory. That's the kind of memory that's more permanent. You won't lose ROM when you shut off the computer. In programming, the computer only understands binary data, and that's zeros and ones. So a bit is the smallest piece of data possible. That's a 0 is off or false. A 1 is on or true. A byte is 8 consecutive bits. And if you take the advanced placement class, we will talk a little bit about how to convert from standard our standard counting system, which is a base 10, to binary, which is a base 2. And then a word will usually hold 4 consecutive bytes. Also, just a little tidbit, there is something in between a bit and a byte called a nibble, N-Y-B-B-L-E, and that happens to be 4 bits. Secondary storage, this is the off disk, or you guys probably don't even recognize some of these pictures, but that would be your flash drives or your Google Drive, etc. Input devices, output devices, software. So system software, and the reason that they put this slide in there is there's a difference between application software and system software. So you should be aware that system software is, when we talk about the Windows system or we talk about the Mac system, operating system, that's the system software. Unix or Linux is another system software. Programming languages are what we use to code instructions for the computer, and we are learning C++ at this time. An algorithm is a set of instructions to perform a task, and the steps must be done in a particular order, and that's what we tell the computer to do when we program. You have low-level languages, which are more likely to be closer to binary. Assembly is an example of a low-level language. And you have high-level languages, which are closer to human language, which is what we program in with C++. From a high-level program to an executable file, there is a process that is followed, and we create a file containing the program. That's our source code file. That's the .cpp file that we have talked about. It runs a preprocessor to convert source files to source code programs, and then we will compile it, which converts the source code to machine instructions. So when we hit the green button in our Visual Studio environment, it is doing the compiling. And then there's a linker. The linker connects the hardware-specific library codes to the machine instructions, and it produces what's called an executable file. I'll talk a little bit about this in another video, and we'll look at what it looks like in Visual Studio. Steps B through D are often performed by that single command click. Errors occurring at any of the steps will prevent the execution. This is the picture that your textbook has. So the source code is your .cpp file. Those /include directives, those are the preprocessor directives that we use, and that actually takes and copies in all the source code that is necessary to run this program up here. So when we use #include IOStream to use cin and cout, the preprocessor then copies all of the necessary files into our source code. We never see that, but that's what it does. Then it runs it through a compiler, and it creates what's called an object code, a .obj file. That then goes to the linker and creates what's called an executable. I will show you this in a Visual Studio program in a few minutes, or on another video. And then common languages, we've already looked at some of these things. There's keywords in common languages. There's syntax, that's placing the semicolons. There's operators such as your add, subtract, multiply, divide. There are other operators, and we will talk about them as well. And we have already in class talked about a beginning program in C++, but this is some examples from your textbook. I'm not going to spend a lot of time on these. Reserved words can only be used for you can't use them anywhere else. Okay, so using namespace, those are reserved words. Int is a reserved word, and they are usually written in lowercase. Programmer defined identifiers. This is what you guys would be, what I call variables. So an identifier is the name of a variable. num1 is a variable, and it has specific ways that you should name them. We've talked about those in class a little bit, but using the lowercase to start with is one example. That's an example of what we call camel casing. Operators, these are your math operators, and then we have an assignment operator. Whenever you hear me say the word assign in class, I am meaning a single equal statement. To actually test for equality, you need a double equal statement. And in class, we also talked about the fact that there is more than just the regular division. Punctuation would be the commas and the semicolons. So this is showing you different ways that you can assign a double. You can assign more than one on a single line if you'd like with the comma. And then lines versus statements. A single line ends in a semicolon. Single line ends in a semicolon. And actually a single statement in coding ends in a semicolon. I could actually put this particular code on 3 different lines, and it just looks for the semicolon to end the statement. Okay, so generally we have one statement per line, but when you have decision statements such as if and stuff, they will run onto multiple lines. Variables, they are also called the identifiers, but a variable that is used to declare specific data is a single place in memory, and it does 2 things. It creates the name of that location, and it tells it what kind of space to set aside. So double sets aside a specific space. Whenever you're programming, we also follow this IPO, input processing and output cycle, and just the idea that we're going to get data, we're going to process the data, and then we're going to output data, and we call that an IPO cycle. The programming process. We've talked a little bit about this in our introductory classes, but basically you have to understand the program before you can actually code it. We will get into designing hierarchy charts, flowcharts, and pseudocode later on in the course. And then you want to check the model for logic errors. We will also talk about that. I call that using your desk checks or checking your data. And then you write the source code, which is your .cpp file, and then you compile it and debug. Correct any errors. This is the programming process continued, and you link the program to create an executable file. You run the program using your test data, and then correct any errors. And then it's a cycle, so it continues again and again and again until it is done. Those are the end of the slides for the chapter 1. I will do another video that talks specifically about that linker and a few things in there, and we will also talk about how to find these different files. If we go back, how to find the OBJ file and the .cpp file and the executable file.